Hey guys, Andrew here again. What we're going to be going over in this video is ways to take derivatives of certain types of functions. So in the example that they give us, we have the derivative with respect to x of the function f of x and the function x squared. So anytime, like we did in one of the previous videos, when I notice this may look a little complicated for me, I'm going to try to make it look more familiar so I can solve it. So the one thing I want to stress is that this term here means the derivative let me erase that so I can actually spell derivative correctly. I can't spell my way out of a box, so do forgive me. Derivative with respect to x. And so we know that that's now a label. It's not, I can't cross anything out, and you'll see later how that comes to light. But for this, we're going to then substitute in a term that makes a little more sense. So instead of this f of x, we're going to declare that as just the x. So now I can rewrite the derivative with respect to x of the function x multiplied by the x squared. And we like this because then we can just multiply, and like we did before, we can add the exponents because the bases are the same. I'm going to now get the derivative with respect to x of x cubed. And from here we just have a power rule where we bring the 3 down when we take the derivative, and we subtract 1 from the exponential, and we just get the 3x squared. When I was explaining this to my friend Barney, and he's a really cool guy. He works at Goliath National Bank. He has he has a lot of success. Although he doesn't really have the concept of a product of two functions when taking the derivative. And he asked, well, Andrew, why can't I just take the derivative of each term and then multiply them together? And I said, Barney, let's just go ahead and take care of that. So I have the derivative with respect to x of this here. And what Barney was saying is that I'm going to take the derivative with respect to x of the function x and then multiply it by the derivative with respect to x of the second function here, and then multiply them. So when I take the derivative with respect to x, I'm going to get 1, and I'm going to multiply it by the derivative with respect to x of x squared, which gives me the 2x, and then I get the 2x as my answer. And we see how that is incorrect. When we have a product of two functions, we have a type of rule which helps us solve this, which is called the product rule, coincidentally, when we're taking a product, right? Pretty simple. Well, not so simple. Product rule. And what the product rule tells us is if I am taking the derivative with respect to x of two functions, that instead of doing it the way my friend Barney did it, what this tells us is I'm going to take the derivative with respect to x of the first function while multiplying it by the original second function. Then I'm going to be adding it, and that helps us out because we all like being positive, right? And so now I'm going to take the original first function here and keep that the same, but then I'm going to take the derivative take the derivative of the second function with respect to x. And so when we work out our problem here, the way Barney did it, we see how his way is a little incorrect. So let's go ahead and take care of this, and then we'll get back to the problem at hand. So I'm going to take the product rule of this function. So I've got the derivative with respect to x, and I'm going to label this as my first, and then this as my second function. So now I'm going to have the derivative with respect to x of the term x multiplied by the x squared. Then I'm going to be adding the first function, the first original function, multiplied by the derivative with respect to x of the second function here. From here we get this, and now we want to make sure, okay, and we just double check it when you just get into a nice repetitive way of, okay, I'm not guessing, but I'm checking to make sure it's correct, and it is. So then I can go to the next step in solving it, which I take the derivative, I get 1 times the second function x squared, adding it to the x of the first function here, and then the derivative of the second function, which is 2x. Really distinguish those, and then we can see here that we get an x squared plus an x times a 2x, which we get a 2x squared, which then gets our 3x squared. And that looks really nice because then we just prove that both methods work and that we get the same problem, the same answer, either doing the product first or doing it by the product rule and then taking the derivative. Now, going to our original problem here, what we're going to do is solve this. So I'm going to do the product rule of this where I have the derivative of the first function, in this case, is just my f of x as my first and my x squared as my second function. So I'm going to distinguish those so we don't get confused, or I don't get confused because that happens to me sometimes, and as we saw, Barney gets confused as well. And then multiply it by the second function, adding it to the first function, then taking the derivative with respect to x of the x squared. So when we go ahead and solve this, we see that the f of x, if we did keep it in this term where f of x equals x, you would do the derivative with just as the x, but because it's just the f of x, we're going to keep that the same. The derivative with respect to x of f of x multiplied by the x squared, and then adding it to, again, the first function f of x, and then actually taking the derivative of the 2x, so the x squared, and we get the 2x. So we see here that we have two different ways, but both ways are correct. But we have if I'm substituting in a value to make this problem look more familiar and getting it into a way that really looks familiar to solve it using the power rule. If I just want to keep it this way and then solve to check to see if it works, I have a product rule that I can really use. Yes, Amy, go ahead.
Could you go into why you could substitute x for f of x?
Yes, I can. So you're asking why I can do this step here. This is a way to make this problem look a little more familiar. So I'm going to move this down here, and I could have chosen anything. I could have chose f of x to be x squared. I could have chosen it to be x cubed. But the reason why I chose x is because when you do the power rule of x, we just get 1. And that made it really kind of familiar because that's how we start with the power rule. And when you're substituting, you can choose any type of substitution you want, and to make it look more familiar to you, or whatever it would make it look familiar to you, and whatever you feel comfortable with. All right, thank you guys so much for watching, and I'll see you in the next video.